Okay, so let's talk about another test that we use in helping us identify where we should be looking to find zeros in our polynomial functions. And that is this, the rational zeros test. It says the possible zeros of a polynomial will be the ratio of factors with the constant term to the factors of the leading coefficient. That is to say, if p over q is a real zero, we have a rational number that's a real zero, and it exists, it will be a rational zero where that fraction p over q is equal to positive or negative factors of the constant term over factors of the leading coefficient. Again, these are possible places for us to, well, in effect, guess where the zero actually is. They aren't the actual location of the zeros, just places that we should be looking. Because when we use this test in combination with our synthetic division and our intermediate value theorem and a lot of those other things, we're actually able to very quickly determine where we have some zeros. So let's look at this one. What do we mean by rational zeros test? All right, this test says if we have a rational zero, if p over q is a rational zero, then what will happen is that we'll have a rational zero by taking factors of our constant term, and in this case, our constant term is the number at the very end, so we have to have that form. Factors of 18, which is our constant term at the end, and we're going to divide that by factors of our leading coefficient, which is 4. All right, so what does this do? Well, we're going to actually list out our factors. What are some of the factors of 18? Well, we know that 1 is always a factor of every number, so we include that in our list. So is 2 in this case, because 2 times 9 is 18. So is 3, because 3 times 6 is 18, pardon me. 6, because of 6 times 3. 9 and 18 are all factors of the constant 18. The factors of our leading coefficient, 4, include 1, 2, and 4. So what we do is that we start writing up a list of possible places where we should be looking for zeros of our polynomial function. The places that we should be looking are going to include 1 divided by 1, 2 divided by 1, so plus or minus 2, 3 divided by 1, so plus or minus 3, 6 divided by 1, so plus or minus 6, 9 divided by 1, so plus or minus 9, and of course 18 divided by 1, which is plus or minus 18. But we still have more on this list, right? Because what we're going to do is we're also going to look at any numbers divided by 2. Well, that includes in this list plus or minus 1/2. 2 over 2 we've already covered, right? 2 over 2 is 1, so we don't need to repeat that. But 3 over 2 is another possible location of a zero that we could find in this polynomial. Plus or minus, let's see, 6 over 2, that's been covered because 6 over 2 is 3. But 9 over 2 has not been covered, so plus or minus 9/2 would be a possible location of a zero. And 18 over 2 has been covered because that's equal to 18. Then we go to our factors over 4. We could have plus or minus 1/4 as a possible zero. We could have plus or minus, well, 2/4 has been covered, that's 1/2, but 3/4 is another possible rational zero. 6/4 reduces to 3/2, we don't want that, but 9/4 is another possible zero. That's it, right? 18 over 4 reduces to 9/2, and we don't have any other factors in our denominator to rewrite. So this list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers right here constitutes plus or minus each one, constitutes our list of possible rational zeros. Possible rational zeros. It doesn't mean that all of them will be real zeros. In fact, only a few of them are, and they only list the rational zeros. It doesn't account for things like irrational numbers like radicals or anything else that might be zeros. But if there is a rational zero that exists, and it is a zero of this polynomial, it will be somewhere in this list. As a matter of fact, I'll just show you. This is one that we don't need any special rules to know how to find the zeros of, because this is factorable by grouping. I'm sure some of you might have already noticed that, but let's just show you. P of x is the same thing, in this case, if we look at our first two terms, as saying 4x squared times x minus 2 minus 9 times x minus 2. Right? And we note that this becomes 4x squared minus 9 times x minus 2. And 4x squared minus 9 factors as 2x minus 3 and 2x plus 3, all times x minus 2. And so what have we just discovered? But that our zeros are actually at x equals 3/2, and that's on this list, x equals negative 3/2, which is also on that list, and x equals 2. Right? So there are rational zeros to this polynomial, and they are at values that are on this list. That's it. That's what we're trying to find. Okay, more tests to come.